In this video, we're going to take a look at the generic reaction of substance A going to products. And we're going to sketch the linear plot for each reaction order. We're going to learn how to extract the linear form of the equation from the plot, directly from the plot, and identify what the slope and y-intercept are telling us, including units. So we'll start with original data, and the original data does correspond to the zero order plot. If original data are linear, then that means that that reaction order is zero order. This plot shows concentration of A, where the brackets mean molarity. So we have the molarity of A, and we'll just go ahead and write those units, versus time, where the units of time can be minutes, seconds, sometimes hours. For the purposes of this video, we'll use all of our time units as seconds. So we have concentration of A versus time. For zero order, the linear data will look like this, where the slope is equal to negative K, and K is the rate constant. The y-intercept will always be the original concentration displayed as whatever function we have on the y-axis. So in this example, the y-axis is simply molarity. So that means that our y-intercept will also be molarity, and we indicate the molarity of the original substance, the original molarity, with the little not symbol or the subscript 0 outside of the brackets. So taking this plot, we're going to substitute the parameters of y, m, x, and b into the linear form of the equation. So y is simply what we have on our y-axis, which is A. M is negative K. Need to make sure we include that negative sign. The x-axis is T for time, and our y-intercept is the molarity of A naught. Taking a look at the units for both slope and y-intercept, the units of slope are always y units over x units. If you run into a situation where one or both of the axes has a parameter that is unitless, then you just include the number 1 instead of the unit. For y-intercept, the units are always the same units as the y-axis. It's really important to understand how the units correspond to these terms in the linear equation. I think it's not difficult, but it's new, because usually in a math class, when you're determining a slope, it is strictly a number. But here, we're looking at data based on measurements, and so we really do have to consider the units. Our units of slope are the y units, which are molarity, divided by the x units, which are seconds. And so the units of slope, which are the units of K, are molarity per second. And you'll find that a lot of times we will write this all in the numerator, showing inverse units. So we would write this as molarity times inverse seconds. For the y-intercept, because the units are the same as the y-axis, then they will simply be molarity. So the units of A naught are molarity. The first order plot is a plot of ln, natural log of the molarity, versus time. The x-axis is the same in all of these plots. The units of the y-axis are unitless in this case because you can't take the natural log of a unit. So we just leave it like that. The linear curve looks like this. Our slope is again equal to negative k, and our y-intercept will be the same function as the y-axis, only for a naught instead of a. So that means our y-intercept in this case is ln of a naught. So incorporating this plot into our linear equation, our y term is ln a, m is negative k, x is still t, and our y-intercept is ln a naught. Looking at the units of slope, still y units over x units, but in this example, because the y-axis is unitless, we just put a 1, and then our x units are still seconds, and we can rewrite this as inverse seconds. And these are still the units of k. I think it's important to recognize that while k is always the rate constant, its units depend on the reaction order. And so it is not always the same units for k. You really do have to figure them out based on the specific situation. For our y-intercept, the units are the same as the y-axis, and that is still unitless. Our second order example is a plot of the inverse of molarity. So 1 over a, because the y-axis, that function has molarity in the denominator, then the units are also in the denominator, which means the units are inverse molarity. The common mistake is to say that the units of this plot, this y-axis, are molarity, but they are not. It is inverse molarity. You always have to be really careful when there's an inverse function. X-axis is still the same. This example is a little bit different because we have a positive slope. So now m is equal to positive k. And our y-intercept still does what it did in the other plots, is it takes on the function of the y-axis. So b, in this case, will be 1 over the original molarity. So pulling that linear equation out of the plot, our y term, 1 over a, m is positive k, x is still time, and our y-intercept is 1 over a naught. Looking at the units of slope, y units over x units, the y units, inverse molarity, x units, seconds. When I go to extract the units from a plot, I will always put whatever is the y unit in the numerator first, whatever is the x unit in the denominator, and then I will clean it up. And I think that's a really good way to go, so that way you don't accidentally invert something that shouldn't be inverted. So in this case, as I've written it originally right here as m to the negative 1 divided by s, it looks kind of funny. So we're just going to clean that up as m to the negative 1, and then bring that seconds to the top as inverse seconds. And these are the units of k. Looking at our y-intercept units, they are the same as the y-axis, and so they will be inverse molarity.